Dear students, following question is a 1 mark question from topic of limit state design concepts from topic chapter of concrete structures. In this question, it is asked that as per IS 456-2000, the minimum depth that is required for slab portion AB to satisfy deflection criteria. Again, it is talking about limit state of serviceability like last question, assuming modification factor to be unity. Now this modification factor is already given as unity. We'll talk about what this modification factor means. But if we talk about the minimum depth required, in fact this is minimum effective depth. So clause 23.2.1 of IS 456 says that ratio of span is to depth for cantilever, simply supported and continuous should be less than 7, 20 and 26 respectively, to satisfy the deflection check. Now in this particular beam, it is a continuous type. This type of slab, they are continuous over support B, that is AB is also extending towards this side, BC is also extending towards this side, and AB is also extending beyond B. So clause that is continuous will be having span is to depth less than equal to 26, that is depth should be greater than span. Now span in this case is given as 6000 divided by 26, which something comes around 230.7 mm. So the closest choice being B is the correct choice for given question. Thank you. Okay, let's talk about modification factor also. Just ahead of clause 23.2.1, a curve between. Now you can see in figure 4 of IS 456-2000 that modification factor is nothing but a relation between Fs, that is stress in tensile, where Fs is in fact defined as 0.85 Fy into area of steel required, area of cross sectional of steel required divided by area of cross section of steel provided, and with respect to Fs we take percentage tension reinforcement and obtain modification factor, and whatever modification factor we obtain, we multiply it by limiting values of span is to deflection ratios, that is 7 for cantilever, 20 for simply supported and 26 for continuous type of beams or slabs. Since we design slab as a beam of unit width, so right now in discussion beam and slab will mean same thing from design point of view. Now once this Fs is obtained and percentage tension reinforcement is known, we can calculate modification factor, and in given question it is already mentioned that this modification factor is unity, hence 26 needs to be multiplied only by 1, keeping answer as same despite of any modification factor, that is 26.230.7. Thank you.